Vulnerability scanning is the next phase of penetration testing after information gathering. While reconnaissance tells you what's there, vulnerability scanning tells you what's broken. In this video, we'll cover CompTIA PenTest plus Chapter 4, Vulnerability Scanning. Let's start with the overview. Automated vulnerability scanners are capable of rapidly scanning systems and entire networks to seek out previously unidentified vulnerabilities. Vulnerability management programs seek to identify, prioritize, and remediate these vulnerabilities before an attacker exploits them. Penetration testers leverage these same tools to develop a sense of an organization's security posture and identify potential targets for more in-depth probing and exploitation. Before you scan anything, you need to understand the requirements. These may come from regulations, corporate policy, or penetration testing objectives. PCI DSS prescribes specific security controls for organizations that handle payment card transactions. It requires both internal and external scans on at least a quarterly basis, remediation of high-risk and critical vulnerabilities, and external scans must be conducted by an approved scanning vendor. FISMA requires that government agencies comply with a series of security standards, including vulnerability monitoring per NIST Special Publication 853. Even organizations without regulatory requirements often mandate vulnerability scanning in corporate policy. Once you understand the requirements, you scope the scan. What systems will be included? What tests will be performed? You identify scan targets based on data classification, system exposure, services offered, and whether the system is production, test, or development. Automated discovery scans help build an asset inventory. Then you determine scan frequency based on risk appetite, regulatory requirements, technical constraints, business constraints, and licensing limitations. Active scanning provides high-quality results but is noisy and may be detected. It can also accidentally exploit vulnerabilities and disrupt production systems. Passive scanning monitors network traffic for signatures of outdated systems and applications. It's not a replacement for active scanning, but a strong complement. When configuring scans, you customize the sensitivity level, enable or disable specific plugins, and use templates for common configuration. Be especially cautious when scanning fragile systems like industrial control systems, IoT devices, or medical equipment. You may want to test scans in a non-production environment first. Scan techniques matter during penetration tests. Stealth scans avoid detection by using techniques that minimize noise. TCP connect scans are the default but incredibly noisy. UDP scans are slower but less noticeable. Authenticated scans use credentials to access target servers and retrieve configuration information, improving accuracy. Unauthenticated scans provide the view of an external attacker. Scan perspectives include external scans from the internet, internal scans from the corporate network, and agent-based scans that provide the most accurate view. Virtualization and containerization introduce unique challenges. Services exposed only within virtualized or containerized environments may not be detectable by traditional network-based vulnerability scanning. Host-based agents provide inside-out vulnerability scans by installing small software agents on each target server. Always use the principle of least privilege for credentialed scans. Software security testing is another critical area. Static code analysis reviews code without running it, finding flaws that other tests might miss. Dynamic code analysis tests the software with execution and input. Fuzz testing sends invalid or random data to detect crashes and input validation issues. Web application scanners like Nikto, Nessus, and OpenVAS identify problems with applications and their underlying infrastructure. When vulnerabilities are found, you need a remediation workflow. Prioritize by criticality of the systems affected, difficulty of remediation, severity using CVSS scores, and exposure to potential exploitation. Test fixes in a sandbox environment before deploying to production. Your penetration test statement of work should define when to report vulnerabilities to the client. Critical vulnerabilities may require immediate disclosure. Finally, be prepared to overcome barriers to scanning. Service degradations are the most common objection. Tune scan intensity and coordinate timing with operational schedules. Customer commitments like MOUs and SLAs may create barriers. Involve customers in planning. IT governance and change management processes may create bureaucratic hurdles. Work within these processes to obtain the resources and support you need. Key exam essentials: vulnerability scans automate tedious penetration testing work, but may attract attention. Select targets based on discovery scans and asset inventory. Configure scans with appropriate sensitivity, plugins, and authenticated versus unauthenticated approaches. Maintain scanners by updating software and plugin feeds regularly. Use a consistent remediation workflow. Overcome barriers from service degradation, SLAs, and governance. Know your key tools: Nessus for commercial scanning, OpenVAS for open source, Nikto for web applications, and Trivy for containerized systems.